Alright, people. Today we're talking about lesson 8-6 square roots and cube roots. The big idea in this case, if a number is a square or the cube of a second number, then the second number is a square root or the cube root of the first. So, for instance, we know that 6 times 6 equals 36. Therefore, which 6 times 6 is also 6 squared. Okay? So we know that 6 is the square root of 36. Why? It's because it took 2 times multiplying by the same number to give me 36. Now, same thing is in essence for cube roots. Cube roots, the only difference is it's to the third power. This is to the second power. This is to the third power. Okay? Cube roots, well, we know 4 times 4 times 4 gives me 64, which is also 4 to the third power. So what we say in this case, 4 is the cube root of 64, because you need 4 times 4 times 4 3 times to give you 64. Where did all this come from? Areas of squares and powers of squares. It says the second power x squared is a number x. It's called the square of x, or x squared. Okay? We always called it to the second power squared, because it is an area of a square with the side length x. Okay? Here in this case, our square is length 3. So this side's 3, this side's 3. So to find the area, we take 3 and square it. It's going to give me the area of this whole square, which in this case would be 9. Okay? Here in this case, this square, we don't know how long it is. It's our x. If this is x, remember all sides of a square are the same length. So this is x. To find the area, it is x squared. If we knew what x was, we could go ahead and find it. Definition of a square root. If area equals s to the second power, or s squared, then s is a square root of a. Okay? So, for instance, 49. If area equals 49. Okay? Well, area, to find the side of that, okay, if my whole thing in my square equaled 49, to find my side lengths, I'd have to take the square root of 49. Now, we all know there's a positive and a negative number that's going to work for it. 7 will work. 7 times 7. Okay? And also, a negative 7 will work. But if we're working in real-world situations, you can't have a negative 7 beam. You only have a side length positive 7. Okay? And when we're working on these, most of the time, all we're going to be working with is positive numbers. The radical sign. The radical sign indicates a square root is being found. There's an imaginary index number 2 here. The horizontal bar attached to it is called the vinculum. Okay? We call this right here the vinculum. Acts like parentheses, which means you need to do that first. The order of operations applies. So work is done inside the radical sign before the square root is taken. For example, the square root of 16 minus 9. Notice the vinculum covers 16 minus 9, so we got to do that first. What's 16 minus 9? Well, that is the square root of 7. Okay? In dealing with square roots, it helps to know the squares of small positive numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. Very important to know those off the top of your heads. That way you don't have to always go to your calculator every single time. Let's look at example 1. What are square roots of each number? So we want to know numbers that will multiply to 64 by itself 2 times. Okay, so we want to know what the square root of 64 is. Well, what times what gives me 64? You're going to say 8 times 8 gives me 64. And you should remember a negative 8 times 8 gives me 64, because a negative times a negative then is positive. What you want to do is find some number multiplied by itself that gives you this number. 8 times 8, a negative 8 times a negative 8. Okay? So what you could say is your answer is plus or minus 8. Now, like I said, once we get into some real world situations, you're going to primarily only use this positive 8. Now, this problem right here, the square root of 17.3, okay? Probably not a problem you can do in your head. So, we need to go to our calculators. So here we are on our calculator. To get the square root is right here in blue, if you can see that right there. Okay, so I'm going to hit second function, square root. Okay, and the number I want underneath there is 17.3. Let me get rid of this right here. Seems like it gives me a little bit more room. So 17.3, I hit enter. So the square root of 17.3 is, like I said, keep your plus or minus. The square root of 17.3 is plus or minus 4.1, and you could probably round it to 6. Now, what you need to remember is this is not an exact answer. If you typed in 4.16 and multiplied it to itself again, it is 17.3056. So it's actually a little bit bigger, but what we call this then is an approximation. 4.16 is the square root. Okay? Both those will work. It's not an exact answer. If you wanted to leave this as an exact answer, you would have to leave it as the square root of 17.3 because you can't get an exact answer. Okay? So moving on. I think that's what we're going to talk about right down here. The mathematician Pythagoras and his followers, the Pythagoreans, were able to prove that numbers like square root of 5, square root of 17.3 are not equal to simple fractions or ratios. Today we know that there is no finite or repeating decimal that equals the square root of 5. So that means 3/4 is not going to equal the square root of 5 or whatever fraction that's very, very close to that number. We can't get an exact answer. While the square root of 5 is approximately 2.23606,797, the decimal does not end nor repeat. You should check the squares of truncated forms that are very close to 5. For example, 2.236 times 2.236 is very, very close to 5, but it's not quite yet to 5. Only square root of 5 and a negative square root of 5 square exactly to be 5. So this is a very, very important property right here. The square of the square root property. For any non-negative number x, okay, the square root of x times the square root of x equals the square root of x squared, which is going to give you x. So for instance, the square root of 3 times the square root of 3 equals the square root of 3 squared, which equals 9, which is going to give you the side length 3. Okay? You can use this property to simplify or evaluate expressions that are exact, rather than using your calculator to deal with approximations. Okay? This is a very handsy way. Okay? We don't know what the square root of 2 is. Square root of 2 times the square root of 2 equals square root of 4, which is equal to 2. Okay? Square of the square root property. Here it says, explain why 4 square root of 10 times 3 square root of 10 equals 120. Very important. Probably seen one of these on your Iowa Test of Basic Skills. Okay? If we're multiplying, okay, we take 4 times 3. Well, what's 4 times 3? 4 times 3 is 12. Here's my square root property that we just talked about. Square root of 10 times the square root of 10. Well, what's the square root of 10 times the square root of 10? Well, it's the square root of 10 squared, which is 10 times 10 is 100. Okay? Do we know the square root of 100? Yes, we do. The square root of 100 is 10. We're still multiplying here. This says 12 times the square root of 100. So if I take the square root of that, the square root of 100 is 10. What's 12 times 10? Well, 12 times 10 is 120. Okay? Going to the Pythagorean theorem. The Pythagorean theorem is, okay, c squared equals a squared plus b squared. You need to put that in your notes. Very important piece of information you're going to use for a very long time. A and B are what we call legs. They are legs of the triangle. C is called the hypotenuse. Mr. Johnson has a very good math joke about hypotenuse. Hypotenuse is the longest side in your right triangle. It is the upstairs bathroom is in use. Hypotenuse. Aha. Okay? As I just said, the Pythagorean theorem can only be used with right triangles. Okay? Can only be used with right triangles. What does a right triangle look like? Well, it has two legs that form a 90-degree angle. And it has a side opposite of that 90-degree angle, which is called the hypotenuse. Side opposite of 90 degrees is the hypotenuse. Now, we know this is C. Okay? We can call this B. We can call this A. It doesn't matter which you call the legs. Okay? You can't mess those up. Okay? B is a leg, A is a leg. You can interchange those. But what does this Pythagorean theorem says? Well, this says if I find the area of this side, which is now b squared, and I find the area of this side, which is now a squared, if I add those two things together, it's going to give me the area of this side, which is now c squared. So what this says is if I find the area of A and find the area of B, so if I square A and I square B, that has to equal the same amount of C squared, which is the area of C. And that's where the Pythagorean theorem came from. So what happens is if I know 2 out of these 3, I can find the side length of the other one. So let's get into that. Example 2 says, use the Pythagorean theorem to find the length of the missing side. What you should notice is, I know the side opposite of my right triangle, so I know what C is. Okay? I'm going to call this side B. I'm going to call this side A. So I'm going to put it into my equation. C squared equals A squared plus B squared. Okay? What's C? C is 14 squared. What's A? A is my M in this case, so it's M squared. Plus B. What's B? B is 12 squared. Well, it helps to know what 14 times 14 is. You all should be telling me it is 196. I just took 14 times 14. What's 12 squared? 12 squared is 144. It's just regular math. We're solving for M. The inverse of adding 144 is subtracting 144. M squared's left over. 196 minus 144 is 52. To find what that is, what M is, we have to take the square root. The square root of M squared is M. The square root of 52, whatever I do to one side, I do to the other, is plus or minus, okay? And if you go to your calculator, I don't think we're going to get a very precise answer. So we could leave it as the square root of 52. Or if Mr. Johnson asks, go ahead and approximate it, put it in decimals. You could say it's plus or minus, and we go to the square root here. .21, let's just say. So approximately plus or minus 7.21. Now, if we knew what these were, say centimeters, meters, whatever, you would have to label that. But in this case, we don't know what they are labeled. We don't know how long these are. These could be millimeters. And so we'll just leave it as our answer as this. Okay? So if you wanted the exact answer, you would just leave it as the square root of 52. If they wanted us to approximate the answer, you're going to write it as plus or minus 7.21, which is what you would have got off your calculator. You're not going to be able to do that in your head. Okay? Moving on. Cube roots. Cube roots work the same as the square roots. The only difference is you're going to multiply it 3 times now. So as I said here before, the third power x cubed of a number x is called the cube of x, or cubed, because it is the volume of a cube with the edge x, okay? When you cube something, it refers to the volume of something. For example, a volume of a cube with the edge length 6 inches is 6 times 6 times 6, or what is 216 cubic inches. We write 6 cubed as 216, so we say 6 cubed equals 216. Like the square, this is not a coincidence. The ancient Greek mathematicians pictured the cube of a number s as the volume of a cube whose edge is s, also in a manner like that of a square. If the volume of a cube v, volume, then an edge of the cube is called a cube root of v. So for instance, if we wanted to know what, if volume was 1,331 and we wanted to find length s, we would have to take the cube root of 1,331 because some number times itself 3 times has to give me 1,331. Well, if you did this on your calculator, because not always are we going to know this, and to find your cube root, you got to go to math, and it's the number 4. So the cube root of 1,331 equals 11. So in that case, my side would be length 11, because obviously you can't have side length of a negative, and even if it was a negative 11, you can't get a negative 11 times a negative 11 to negative 11 to be a positive 1,331. So in this case, you could only have a positive number as your answer. It says the definition of a cube root. If v equals s cubed, then s is the cube root of v. So in this case, 11 is a cube root of v, in this case was 1,331. Let's look at quiz yourself 2. Fill in the blanks. Since 4 cubed equals 64, we know 4 is the cube root of 64, because 4 to itself 3 times is the cube root of 64. If I took the cube root of 64, I'm going to get out 4. It says the cube root of v is written using a radical sign as the cube root of v. Okay, we just did that. Showed you one of those. You're going to have to do that by yourself. For example, the cube root of 216 is 6. The cube root of a negative 216 is a negative 6. Many calculators have the cube root sign command. That is math. And we said it was number 4. You should try to locate this command on your calculator. We just did that. The cube root of the cube root property, same process as the square root property. Just notice you have these cube root signs here. So you have to have those on there when you're multiplying that by itself 3 times. Okay? So it says, for example, 1.2 cubed. 1.2 times 1.2 times 1.2, these are our sides, gives us 1.728. This would be our volume. This means 1.728 is the cube of 1.2, or how we like to refer it to it as 1.2 is the cube root of 1.728. Okay? The cube root of 1.728 is 1.2. Okay? When the value of the square root or the cube root is not an integer, your teacher may expect 2 versions. Okay, I showed you that. The exact answer written with the radical sign, or give me a decimal approximation with a certain number of decimal places. I normally want 2 decimal places. Okay? So, give me the exact, I want both. So like we did before, the square root of 52, okay, And the square root of 52, if you remember, was 7.211. So, and this was plus or minus, right? So this was plus or minus 7.21. We'd go 1 because Mr. Johnson said 2 decimal places is fine. Now remember, this is just an approximation. That's our symbol for approximation. Okay? There is a lot of information in this lesson. You need to make sure you either watch this once or twice to make sure you get it all. Thank you very much. We'll see you tomorrow.